let's say you wanted to add some depth of field to the shot. This was the original, everything's in focus, and then this would be adding some depth of field, right? So you could totally do this in comp, and in fact, I would recommend that you try to do it in comp if you can, simply so that you have that flexibility to make changes if you need to without having to re-render the entire scene. Even if you're doing that, it is useful to sometimes render this, because then you get a good idea of what a physical version of the depth of field would look like, and then you can use that as reference to dial it in the comp. So if you want to set that up, I'll show you how you can do that. So I've gone ahead and made this Arnold DOF settings node, and this is just a custom group node that I've created. If we dive in here, you'll see it's just an Arnold camera settings node. So you just specify your camera here, and then all you have to do is provide a focus distance. So this is distance from your camera to what needs to be in focus, and then an aperture size. Now, what is an aperture size? Normally we're talking about f-stops when we're talking about lenses, right? So let's go back out here and I'll show you what I did here. So this is a custom node, like I said. This is what it looks like for the interface. So you're going to provide a focus distance and an f-stop and a focal length. And then this unit conversion I'll talk about in a second. So we've got a 50mm lens for this shot. And let's say we want to use an f8 on our lens, right, for our aperture size. What Arnold is going to require is this number here, 0.625. To calculate this, it's just an expression. So f-stop is really a ratio of the focal length. So the f in the f-stop number is the focal length. So if you're talking about an f8, you're talking about a 50mm lens divided by 8, and that's the aperture size. In other words, the diameter of the opening in the lens. So I'm taking this focal length here, 50mm, and then I'm converting it using this unit conversion. And the reason I'm doing that is because if this was set up in Maya, the units in Maya were centimeters. And so we need to convert millimeters to centimeters. So we're going from 50 to 5, so 5 centimeters here, and then 5 divided by 8 is going to give us 0.625. So it's very, very straightforward. And so if you wanted to figure out, so if you want to drop this into any of these passes, you can. The tricky part is this focus distance, right? So you either need to set up an animation, because if you say you wanted to focus on our character's eyeballs here, well, he's walking forward in the shot. So we would potentially have an animated focus distance. And let's just, for this example, I'm not going to bother animating it. You could sample a distance and set keyframes and whatnot. You can also potentially get this set up as an animation channel that's exported, and then you can hook that up somehow. I'm not going to cover that, but for now I can show you a quick way to figure out what that distance needs to be. We're going to use our Z-depth AOV. So if we go to Z-depth here, our little eyedropper up here is going to, if we hold down Control, it's going to give us values, right? And you see it's giving us some pixel values up here. This is the distance. So if we set this to default, and then we control click on an eyeball, and then we change our AOV to Z, then we're sampling, if we sample right close to that, that would be the distance that we need to focus on this particular frame. Okay, so then we would put in 205. And then once we put 205 in there, when we render it out, we would get something very similar to this. Again, this was rendered with 267. That just means that this is a different frame than I originally measured this value from. So he's probably stepped forward. That's why this distance was larger when I measured it. Another thing to note, sampling this is not that accurate in that he's got lenses on his glasses. And so that's probably what I'm sampling is the lens rather than the eyeball. But normally this is a pretty good workaround. Of course, you can use measure tools and that kind of thing in your 3D viewer and stuff. So there's multiple ways you can do it. Again, once you've got this set up, you can go ahead and render it. You potentially might need more camera samples to clean up noise when you're dealing with this stuff. That's the same for motion blur anyway, so you're probably likely going to have lots of camera samples to get rid of the noise. And that's pretty much it for depth of field. I'm not actually going to render this again because I'm not going to animate the distance here, but I wanted to show this to you regardless. And again, I like to do this as an example, and if I was to go back into the comp, I could use this to dial in exactly how much DOF I want it.